Welcome, everybody. Let's get started. Our next speaker is Jack Diederich, a core Python developer.
All right, is the mic on? Yeah, good. So this talk is how to write a function, a little bit about me. This is my 16th PyCon. So I've seen a lot of Python written, read a lot of Python, written a lot of Python myself. And there's some things I say repeatedly when I'm looking at other people's code, things I try to do in my own code. If you've ever seen any of my other talks, they're mostly about code quality, just how to do simple workman-like things. You know, your job is hard enough without people trying to clever up the place. So this is a bag of little tips and tricks, things I say frequently in code reviews. When I talk about code reviews, this is the one place most of you are going to get feedback on what you've written. This is kind of your last chance to polish up the code before it goes out. Code reviews are kind of the gatekeeper for publishing code. And they force you to think about the reader. So you read code a lot, like that's a saying. People read code more than they write it. You yourself read the code you write many times before anyone else has even seen it. You read it when you write it. You know, when you're writing tests, you're comparing the code and the tests. You read it before you post it for review to look for typos or anything else embarrassing. The reviewer reads it, depending on your organization, might be multiple reviewers. And then it goes out, and it lasts, give or take, forever until it's deleted. So making the reader happy is very important. When I talk about a function, function is 5, 10, 20 lines of code. A function fits on a page. Most of your interactions in Python are functions. If it's a function that's part of a class, we call it a method, but it's the same thing. It's 5, 10, 20 lines of code. So the reader should be able to walk in and look at a function that's 10 lines long and be able to figure out what it is. If they already have domain knowledge about the module that it's in, it might only take them a minute, but they should be able to read it top to bottom and figure out what's going on. If someone doesn't know anything about what the function's doing, maybe they average like 1 line per minute understanding. So they read a couple lines, they go down, they say, oh, you know, where were we again? And they go back up, but it's 10 lines. They should be able to figure out what's going on in a very short amount of time, and it's your job as the writer to help them. So there are lots of advice for always and nevers. This talk will not have any advice that has an always or never in it. These are things I put in code reviews that usually sound like, hey, have you thought about this other thing? Or have you tried this? What would it look like if you trim this other thing? There's lots of advice on the internet for always or nevers. Here is a very simple function. Prints 3 lines, completely understandable. If someone comes along and says, always make functions 2 lines or less, this is easy feedback to give during a review. You can literally give it on every review, and it's easy advice to action on. And you end up with code like this. So this is strictly followed the rule. There is no function over 2 lines. And the reviewer is happy because he gave you feedback, and you're happy because you action the feedback. And everybody spent effort on this thing, but it's actually not useful effort. So my examples are going to be hopefully useful effort. Broadly speaking, this talk has 3 parts. Thinking about function structure. Again, a function is just not a big thing. You should be able to look at a function and see what it does, but it generally has a flow from top to bottom. Helping the reader. Most of the small examples are things that you can do that just help the reader out a little bit. And again, if you're in a code review, your job is to make it easy for the reader to say yes. It's to make it easy for the reader to say, this function does exactly what is promised, ship it, go out into the world, no bugs. And the final part, which is shorter, is things that don't help. Advice you can find on the internet, things like function shouldn't be longer than this number of lines, and things to be on the lookout for. Function structure. Functions, once again, small bag of lines. At the top, you have input. This is where you get the things that you are going to do. In the middle, there's a transform. This is kind of where you add information to the system. You're taking the inputs and then doing something to them that adds value. And output. At the end of every function is a return. So this is what you are giving back to the reader. On Twitter, I tried to brainstorm some catchy names for this concept. I was not successful. But really, a function should be unexciting. Your job in a code review is to surprise no one and go on and get your job done. So the cone of boringness, the funnel of predictability. Let me know if any of these names catch on. That would, yeah. So thinking about function structure. The first thing that happens at the top of a function, you were given some inputs, or maybe you have to go out into the world and ask the database for some stuff that you need. But input is where you're setting up expectations for the reader. You are gathering up all the state of the world that will exist inside this function. So at the top, once the reader has read the first few lines, they should know, okay, he has an address and a user. I bet I know where this is going. And then it should go there. So at the top, gather up the information you need. Throw out everything you don't. So again, this makes it easier for the reader. If the database query that you do returns more information than you need, throw out the stuff you don't need. And this tells the reader, here is the two things that we're going to care about in this function. And then when you use those two things, they're not surprised. Early errors are good errors. So when you're gathering up just the information you need, if you don't have the information you need, abort. You're not going to be able to do the job that the function says it's going to do. So just bail early with a nice error. This not only makes it better when you're calling it, because you get these big loud errors, but it makes it easier for someone to review, because they know they don't have to read the rest of the function to know these things are true, and that's all you need. On that note, Asserts Add Information. So you are telling the reader that these two things are true. Keep reading. Transform. This is the middle. So you've set it up. You have all the information you need to continue. And this is where you collate people and addresses. This is where you do matrix multiplication. This is where you create something that has more value. The reader should be bored at this point. They've seen the inputs that you have. They know the name of the function is transform matrix. And in the middle, you are going to transform the matrix. Great. We like boring readers. Output is, think of it like a printy printer. So you've already had the inputs. You've had the transform where you do the work in the middle. And the output is creating whatever is useful to the caller. So the function name might promise that you're returning them a list of names. This is where you might have a dictionary of names, or a set of names if you are making the result unique. But if the function name promises that you're going to return a list of names, this is the point where you take the transform that you did in the middle, and you just turn it into a list of names. Caller's happy, everybody's happy. So inputs happen first. Inputs is where the errors happen whenever possible. So the first thing you should do when you're writing a function is think about your inputs. There's lots of fun practice problems that you can find on the internet. Project Euler, if you want to do lots of stuff with combinatorics or just practice on short problems. Those are great ways to practice programming. They don't help figure out they don't help teach you thinking about inputs, because the inputs to every Project Euler problem are exactly what you need to solve the problem and no more. So in your real day-to-day job, the first thing you have to do when you're writing a function is figure out how to get the information you need. Do I need to talk to the database? Do I need to call a REST API? Was everything passed in as arguments to the function? So the first thing you have to do is figure out what you have and what you want, and then to make it easier for the reader in the middle, throw out what you don't need. Anytime to practice thinking about inputs, anytime you see a board, you can say, okay, how much information is in this board? This is Conway's Game of Life. There's 5 bits of information, which dots are on. A chessboard doesn't have much information on it. It's positions and piece types. And after you have these, then you can figure out what you want to do with them. But just try and think about inputs. So here's an example function. Let's get a palindrome of names. So the promise of the function is I am going to give you a bunch of names that are palindromes. It's right there in the name. Perfect. At first, we have to get some users to get names. So we get a list of users. As a promise to the reader, we then just take all the names from that list. And this kind of hints to the user that here's the thing you should care about right now, which is just a list of names. Then in the middle, we do some work for name and names. Is this a palindrome? All right. So this is the information we've added. We're checking to see which names are palindromes. And at the bottom is a little bit of output. And again, functions are just not a lot of code. So the input, transform, output is not very exciting. But it does go, generally speaking, top to bottom. This is an example of asserts adding information. So if you have a function called getHostConfigs, the fact that the function name has a plural in it implies that it's returning a list. So the getHostConfigs function is going to return 0 or more configs. This is you adding information to help the reader. You happen to know that there is one and only one name that should be returned. It's never going to return 0, because at this point, you are assuming you have a valid config. If you don't, you want to fail. And you are telling the reader that if 2 configs are returned, then something has gone seriously awry, and you should also fail. So you can say assert length of results equals 1. Great. This has very low overhead, and it tells the reader a little bit extra about what's about to happen. Returning early adds confidence. So dry run just means don't do the thing I'm asking you to do, but tell me what you would have done. So this is a very common pattern. Pass the dry run flag. Great. So let's get all the users, and if this is a dry run, then let them know how many things we would have done, and scene. This is good code. This is very readable code. This is code that you will see in a code review. It probably does the same thing, but if dry run, log the info, else, and then it keeps going. So the reader has to wonder, is something else going to happen? The reader now has to scroll down the page and check to see if you actually did delete the users, which would be bad. So just return early when you can. If you've done all the work in the function you intend to do, get out. Great. The gun on the mantle. So in the theater, the expression is the gun on the mantle in Act 1 goes off in Scene 3. Because the idea during a play is you build up suspense. Everybody in the audience knows that there's a gun on the mantle and expects something to happen to it and enjoys the journey as you go through and build suspense. That is absolutely not what you want when you're writing code. The gun on the mantle goes bang. So if you tell someone about something too early, they have to wonder when you're going to use it. And they have to keep it in their mental stack that there's a gun on the mantle. So, just introduce the gun, make it go bang, pick up the next gun, make it go bang. Everybody's happier. And this is kind of our inheritance from C, like K&R style C, old school C. You had to declare everything that you were going to, any variable you might use, at the top of the function. That's just how it worked. So you still see that kind of bleed through sometimes in Python, where they tell you up front, here are 4 variables I might use during this function. And then they use one, and then they do some stuff, and then they use another one, and then they do some stuff. But this is Python. You absolutely don't need to do that. So just right before you are about to use something, declare it. So this helps the reader because they see you define a thing and then use a thing. And then you take the output that was that thing and then you use it again, and everyone's happy. So this helping the reader by introducing fewer concepts at a time, great. Make the job easy for a reader, get your shipits, everyone's happy. Again, a little bit of inheritance from C. It is okay to put constants in default function signatures. So call API, retries equal 3 is great. It's very easy to read. It tells you exactly what's about to happen. We like that. Call API, retries equals max retries. Okay. So, you know, and I said this a little bit more colorfully on Twitter. Lol, go look it up times. It's rarely necessary. You might say max retries is shared. Okay, you can wait until it's shared before you declare it at the top of the file. That's a good thing to do. But in C, there was no way to express this concept. So you had to put it, where do you put your function defaults in C? You don't. Where do you put your constants in C? In the include file, because that's the only place they could be. In Python, you have options, so you know, let's use them. Exceptions. If you've seen some of my other talks, I say exceptions are overused. Exceptions are usually also far away, which doesn't help. So if there's an exception at the top of the module, later on when you go and raise it, someone has to go back, the reader has to go back, check what the definition is, see if it inherits from anything. And in Python, you can usually get away with just reusing an existing error. And this has the added benefit that you don't have to go look up anything. People already know the semantics of built-in exceptions, and everything works great. So names. Names are easy and hard both. Functions are small, so there aren't going to be a lot of names in your function. So you can make names simpler. You don't have to add a lot of context to the names because the reader of a function, you know, if they're 5 lines into a 10-line function, they have all the context they need. Good naming is still helpful. Good names are better than bad names. There's a bunch of little words you can use to tell the reader that they shouldn't care about something. So the name raw is great. The name bytes is also great, except in Python where it's a built-in. So I tend to, anywhere where you might want to use bytes, I tend to use the word raw. What does raw tell the reader? Raw tells the reader this is some data format. It doesn't tell them what format, and that tells them that they shouldn't care what the format is. You're going to be passing around whatever this raw thing is, and then do something useful with it later. It's a function, so you're going to do something with it very soon later. So user equals deserialize user. No one's guessing at what this is doing. So it takes that raw blob that you got from somewhere, and it gives you something that's a user, probably an instance of a class. If you can, you don't even have to use the temporary. So again, this is a function. It's not a lot of, there is a lot of context in a small amount. It's good context. So if you can get away without using a temporary, then don't use a temporary. It's one less thing that the reader has to think about. They don't have to wonder if you're going to reuse raw later. I mean, they shouldn't. You told them it was raw and then you used it. But if you can, if it doesn't get too complicated, then immediately use the return value of the thing. There's no variable in scope. Nobody has to wonder if you're going to use it again. So if you can, skip the temporary. If the reader really, really shouldn't care, there are a bunch of well-known idioms in Python for pretend this didn't exist. You don't have to go around and del individual variables. That's overkill. But if the variable doesn't matter, underscore, very popular. Even people who haven't seen it before probably get what it is. Dummy, perfect. Ignored is very popular in function signatures. This is when you're working with someone else's code or updating an existing thing and you don't want to change all the colors. If some flag is no longer meaningful, set the name to ignored. It promises the reader that this will not be used. The reader should be surprised and angry if 5 lines down somebody checks the ignored flag and you won't get your shipments. So ignored is a great variable name. Ordinality. So how many things are there? You can use variable names to tell the reader something useful about the return value from a function get from API. Get from API could be returning anything. But if you can immediately tell the reader something about what was returned, do. Pair equals items. That's a promise to the reader that there's a pair of things that was returned. That's a pretty good name. Left and right. So this is even better because this will blow up if there's not 2 things. So the reader, now you've told the reader that there's 2 things, and it doesn't even matter if they don't believe you because they believe the computer. And left and right is a good generic thing. So maybe the left one and the right one don't actually have, it's just 2 things. If you actually know something more about them, those 2 things, then you can tell the reader that too with naming a little bit. If there's an old thing and a new thing, old and new, great names. Same thing, primary, secondary. So if you have a pair of things and there's meaning, name the variable with a little bit of meaning, everybody's happier. I did another talk, name things once, who, what, when, where, why. This is who, what, when, where, why. The 5 W's are good when you're doing journalism, not so much for code. Who, you don't really care who, the person who did it. When, Q2 is a terrible name to add to a function. Where is usually some reference, unnecessary reference to another module slipped into the name. So what is for functions? What is this thing doing? What promise am I making? Especially for newer coders, names accumulate that kind of metadata. So again, in a function, you're not going to have very many variables, so you can afford to have short names because there's only 3 things, and one of them is a config. You will see things like config from JSON, and the name is almost a transposition. The name on the left-hand side is almost a transposition from what's happening on the right-hand side, and you will see variables tend to get added to. So the first one had 2 underscores, the second line has 3 underscores, and I've seen this go on for 6 or 7 underscores. But again, this is a function. There's not much happening. There's only a couple things in play in this function. So you can afford to have very short, concise variable names. There's a config, so let's name it config. There's a name. Oh, that's a typo. There's a user, so name is a terrible name for that. Return consistently. So none of the examples I've given in this talk or will give in this talk are the code is wrong. So it's not an example of this code is wrong and bad. It's, here is a thing that gives you bytes, and here's a thing that gives you the same bytes, but is a little bit easier to read. So these 3 functions all give you the same bytes. They all have exactly the same semantics in Python. They're super short, so they're all easy to read. They all set x equals 3, which is kind of a no up here, but they all end up returning none when they're called. If you return explicitly, you're making a different promise to the reader, however. So this is an example of something I'd send back for edit. Compare 2 lists. So if these lists are the same, when they're sorted, return true. Great. And this falls off the end and returns something falsy. So in almost every place you would call this code, it's not going to blow up. It's not going to do the wrong thing. But when you're reading this as a code reviewer, you have to wonder if they did that intentionally or not. So if you're writing code, make it plain that you've thought about this and tell the reviewer that, yes, I know exactly what I'm doing. It either returns true or returns false. Much easier to read. No one has to doubt if you were half asleep. And same thing with returning the same types. This makes it easier for the reader to think about what you meant to do. So a lot of times when you would call calc union, none might be okay. They're either looking for something falsy or a set. But we have another good thing for something falsy, which is an empty list. So now we're returning a list. So the promise of the function and the promise to the reader is we have a function that returns a list. Great, far less confusing. Return the same types from none. So there's a couple ways you can handle failure. Returning none is popular. So either I found the thing you were looking for, or here's nothing. But this also tells the reader that you clearly thought about the missing case, or you can raise an error. So a lot of functions will either return exactly the thing you were looking for or raise an exception. And code should be somewhat consistent. If you go with the exception style, go with the exception style. If you go with the none style, go with the none style. But this tells the reader that you've thought about your failure conditions and have handled them. Keeping it together, so functions are short and easy to write, and short functions are easy to test. If you want things to be easy to think about. So this is perfectly fine code. There's 3 functions. The meat of the thing is actually the validate. So we want to make sure that a config exists and it has owners. Great, here's 3 functions. They just do a couple little things. This is the same code. At the end of the day, it generates the same bytes. What this tells the user, the reader too, in addition, is that these things will always happen in this order. So this config exists and has owners. This interface, this has a bigger surface area. So it kind of hints to the reader that you can call these things at any time. And then that means you have to test for more things. This tells the reader that these things will only ever happen in this order. So you don't have to think about any side conditions where half of these things are true. It will always happen 1, 2, 3. So this makes it a little bit easier to read. Might not make it easier to unit test. I think it's about a wash in the end. Language features. So everyone who learns a language feature immediately starts seeing an application for it everywhere. This is great. David Beasley's 2 rooms over. Bees gives great talks. He takes one language feature and he tortures it to death to learn its secrets. But the moral of the story of his talks is always, here's how you actually want to use the thing. But in code reviews, you will often find, you will see code about the feature that someone learned yesterday. So it is your professional responsibility to learn new things and then to apply them judiciously. I'm leading with the after refactoring first, which will make more sense once you see the before. So this is a simple function that reads the CSV. Great, there's your inputs. The transform in the middle is it's rolling up rows that have the same state and zip, accumulating population, and then at the bottom, for state zip in sorted population, there's your output, your pretty printer. Great. This is a fine function. It does exactly what it says. It's short, it's readable. This was the first thing I saw in the code review for the code that ended up on the previous slide. And again, there is nothing wrong with this code. This code, it's idiomatic Python. It's idiomatic use of classes. It does things well. It defines both equal and less than, which is usually what you want to do if you have one or the other. And there is nothing wrong with this code other than it didn't need to be written. So this was the first thing at the top of the review, and this was the thing just underneath it. So again, this is idiomatic Python. It uses that class, which was also idiomatic, and I mean, this code is actually like somewhat impressive. So it uses the group by function. I don't know how many of you used the group by function successfully. It's 16 years, I'm not sure if I have. So it has a very weird interface that works only in like 1 in 10 cases where you think you want to group by. This is one of those cases. It also uses the reduce function, which is another one of those Python things that looks like it will be useful more often than it is. It has a very peculiar interface. Anyway, so this is fine code. This code does exactly what it means to do. There's no errors. It's great. But it's not this. So this was a case of someone had just learned a bunch of language features all at once and used them all at once. But after we had a sit down about it, we ended up with this code. We did some other discarded refactorings. This one's kind of a clever use of sum and counter. The interface to counter can be a little bit wonky sometimes, and the person who'd written the original code hadn't seen it before, and there were some questions about what sum was. So this might be like a little bit shorter, but it introduced a couple extra confusions for the reader, which at this point was the guy who wrote the code. So we went with a very simple for loop and a default dictionary. So good, got 2 shipments on the code, everybody's happy. So all effort feels like useful effort. Linters, I'm not a huge fan. So the problem with linters isn't that they tell you you have an unused import or some extra spaces on the end of the line. The problem with linters is your coworkers who enjoy linters. So I think it's PyFlakes ships with some horrendous set of defaults and will complain about, not just 81 characters, but it'll tell you that, warning, this line is 13 lines, this function is 13 lines long, and you have to go through and make a config file that turns all these knobs on or off, and then you fight about them. And I mean, yeah, so. 3 people can maintain a linter if 2 of them are dead, something like that. So the whole linter thing, but it feels like you're agreeing on things, and it feels like you're making effort. And then in a code review, someone can immediately jump in and say, the linter's unhappy, and then you make the linter happy, and then everyone feels like they've done something, and half the time you haven't. It's been effort. People can also add their personal preferences to linters, and I don't mean line length. You can actually, linters crawl the AST, so you can add linter rules that, one particular example, so function defaults, you can say x equals empty list. And I think all of us have been tripped up on this once or twice, that empty list is created once and then goes into the function every single time. So if someone starts mutating that list persists. And that trips up people the first time they see it. There are valid use cases, however, for doing that. If the name of the variable is cache, then you quite intentionally introduced a variable list into the method definition. But I've seen people mark that as an error in the linter, and again, then you have to fight about, is this a rule, is this not a rule? So linters can be an attractive nuisance. Language features are also an attractive nuisance. Python type annotations are good what they are good at, which is the type annotations you write should agree with the type annotations you write. So you can spend time making your annotations happy with each other. I don't get it. So, and I'm on the outside on this one, but it doesn't solve a problem I have. I don't pass the wrong types into things. Or if I do it once very, very early on before it's shipped. For me, this is just a lot of extra effort to read and write things, and I have friends who like them, and they're smart people, so there must be something to it, but personally, I just don't get it. And so like, type theory is interesting, I get that. Thinking about types is fun, I get that, but going back to all effort feels like useful effort, I don't get it. So during code reviews, people will say unhelpful things. I am not going to link to any of the things I talk about because I don't want them to spread. So in researching this, I went looking for people's lists of do's and don'ts. People have some peculiar lists. There was one that, it was 50 things you should do in Python. And clearly they started with the number of 50 and then worked backwards to find things. So you can find anyone who will agree with you on the internet. Short functions, people will be very prescriptive about how long a function should be. A function should go on as long as it has to. Return once, this is kind of goes back to like early compiler days. It was helping the compiler to only return once. It was easier for the compiler to reason about things because computers were 50 megahertz. That's no longer true. It hasn't been true for a long time. No if statements is a curious one that has some popularity. And this doesn't mean no branching. That's a completely separate and interesting thing that you do in GPUs. This means don't type if. So there's all kinds of convolutions you can do to not actually type the word if. And they're not pretty. Your program is still allowed to branch. It doesn't mean no branches. It just means literally don't type the word if. So in summary, when you look at a function, think input, transform, output, use sensible names, and avoid unnecessary work. I mean, don't clever up the place. All right, that's all I got. Any questions?
Thank you, Jack. Please come to the microphone if you have a question.
Thanks. So it can be tempting to use, to have a function return a tuple. Say if you input a list of integers, return max, min, average, whatever. What's your take on that? In general, you have to remember the order of the return, or is it better just to return the list?
So the question was, if you're returning a tuple, should you return something that wraps the tuple?
So a function designed to return a list, but you know your users in this program are going to want the max, want the min, want the standard deviation, want the average. So rather than to write the function to return the list, you return the list and all of these cool statistics. You know, it's kind of sloppy, but you know your users are going to use it. Then again, receiving the output of that function gets a little hairy. What's your general take on that?
So the question was, if you're returning a list of numbers, can you also return other things that are transformations of the numbers, a list of averages, a list of mins, a list of maxes? So I'm going to punt on that one. Your function should return whatever the caller expects it to return. And if the answer is it wants a list of mins and a list of maxes, then that's what you return.
You recommended the use of the ignore value or name in the parameters. How do you reconcile that against people's preferred practice to name all their values with keyword arguments?
Can you repeat that?
In your definition of the function, where you say function paren blah 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 blah, to use the word ignored if you're not going to use that value.
Yes.
How do you reconcile that against other people's tendency to say when they call their function, they call all the arguments with their keyword names instead of their positional names?
I don't think I said anything about calling them with.
Right, that's what I'm asking.
Oh, then is the question, when should I pass by position and when should I pass by keyword?
No, how do you reconcile the one against the other. If you have a function that's supposed to be used as it's used in many different places, you don't know what parameters are going to be passed into it, or you do know what they are going to be, but you're not going to use all of them. If you don't give it the name that was given in the parameter definition specification, and it gets called with a keyword value equal that thing, now you have a keyword mismatch and you get an error. How do you reconcile that?
Okay, so I'll rephrase the question as broadly about when do you do positional, when should you do keyword, what makes things easier to read. So lots of people have opinions. The only one I think that is universal is if you're passing flags, booleans, use the keyword arg, because it's very hard to read a function call that says do stuff, true, false, false, true. Yes?
I just kind of similar question, but what's kind of your rule of thumb for using like star quargs? Because I think it might sacrifice some of the readability of the method signature.
Passing star quargs and defining stuff as star quargs does hurt readability. There are places where you do it because you have to. If anyone's used the AWS HOWTO API, it has this weird, I don't know if it's Javaism, I don't know where it got it from, but you can't pass setting equals none. You have to not pass that thing at all. And that's where you end up doing weird quargs stuff and adding to the quargs and then calling it with star quargs. So using quargs is usually a workaround for something else. Anyone else? Thank you.